We will be discussing today about simple and compound propositions. Do you still remember the different types of sentences? Can you classify the following? We have here, a leap year happens every 4 years. What kind of sentence is this? Very good. It is a declarative sentence. What is your name? Very good. It is an interrogative sentence. How about, please sign your name on the space provided? Very good. It is an imperative sentence and request imperative sentence. How about, close the door? Very good. It is another imperative sentence, but at this time, it is a command imperative sentence. How about, oh my God? Very good. It is an exclamatory sentence. A proposition is a declarative sentence that is either true or false, but not both. Being true or false of a proposition is called its true value. Propositions will be represented by letters like P, Q, R, and so on. Let us take some examples of propositions. The month of July has 31 days. Mango is a vegetable. 2 is an even number. 1 is a prime number. The sum of 10 and 6 is 16. Why are they called propositions? It is because they are declarative sentences that is either true or false. We have here some examples of non-propositions. When is your birthday? This is not a proposition. It is because it is an interrogative sentence. Kindly inform your classmates to bring their books tomorrow. This is not as well a proposition. It is because it is an imperative sentence, a request imperative sentence. Get me a glass of water. It is also an imperative sentence. 2 plus 2. So there's a missing thought there. It isn't a sentence at all. Is craving for ice cream. So this is just a phrase. So basically, these sentences or these phrases are not propositions. It is because they are not a declarative sentence. Now let's try to determine the truth value of the propositions. So number 1, the month of July has 31 days. Is it true or false? Very good. It is true. Mango is a vegetable. Is it true or false? Very good. It is false because mango is a fruit. 2 is an even number. Is it true or false? Very good. It is true. How about 1 is a prime number? Is it true or false? Very good. It is false. Why? Because 1 is neither a prime nor composite. The sum of 10 and 6 is 16. Of course, we know it very well that it is true. Now we can symbolize the propositions as follows. So you can see there, the month of July has 31 days. It is being represented by a letter P. Mango is a vegetable with the letter Q. 2 is an even number with the letter R. 1 is a prime number with the letter S. And the sum of 10 and 6 is 16 with the letter T. You can symbolize a proposition using any letter from the alphabet. At this time, you give your own examples of propositions. Okay, can you give also your own examples of non-propositions? Very good. So let's check if you have understood our lesson very well. So let us try to determine the truth value of the following propositions. Number one, Dr. Rizal is our national hero. Is it true or false? Very good. It is true. The scientific name of rice is Rhiza sativa. True or false? Very good. It is true. A baby pig is called a piglet. Is it true or false? Very good. It is true. Plants are living things. Is it true or false? Very good. It is true. How about human beings are immortal? Very good. It is false because we human beings are mortal. Now, let's try to symbolize the following propositions. As I've said, you can use any letters from the alphabet. So in this case, we symbolize Dr. Jose Rizal as our national hero as P. The scientific name of rice is Rhiza sativa. We symbolize it with Q. And a baby pig is called a piglet with R. And plants are living things with S. And human beings are immortal with P. So that is how you're going to symbolize a proposition. Now, propositions can be classified as simple or compound. A simple proposition is a proposition that conveys a single thought or ideas. A compound proposition, on the other hand, consists of more than one thought or idea. Compound propositions are formed by combining simple propositions using connectives. The most common connectives used are and, or, if then, and if and only if. We have here some examples of simple propositions. The month of July has 31 days. Mango is a vegetable. 2 is an even number. 1 is a prime number. The sum of 10 and 6 is 16. So again, why are they called simple propositions? They are called simple propositions. It's because they convey a single thought or idea. We have here some examples of compound propositions. Again, what is a compound proposition? It consists of more than one thought or idea. So take a look at example number 1. Today is Monday and we will have a flag ceremony. So as you can see there is a connective and there are two thoughts there. First is today is Monday and the second one, we will have a flag ceremony. So therefore, this is a compound proposition. Number 2, either you will stay home or attend the birthday party of your friend. So the connective that we are using is or. So we have two thoughts there. First one, you will stay at home, and the second one is to attend the birthday party of your friend. Third example, if a triangle is equilateral, then it is equiangular. So what is the connective that we are using? We're using the connective if then. So we have two thoughts there. The first thought is that a triangle is equilateral, and the second one, it is equiangular. Number 4, I will pass the exam if and only if I study hard. So the connective that we are using is if and only if. There are also two thoughts there. The first thought is I will pass the exam, and the second one is I study hard. So that makes a compound proposition. Now, you can give your own examples of simple propositions. You can also give your own examples of compound propositions. There are four different types of compound propositions, namely conjunction, disjunction, conditional, and biconditional. So let's discuss it one by one. Let's start with a conjunction. A conjunction is formed when two simple propositions are joined using the connective "and". Thus, if P and Q are the simple propositions, then a conjunction is of the form P and Q. In symbolic form, we write it as P dot Q. So take a look, no? There's a dot in between P and Q. The propositions P and Q are called conjuncts. The truth value of a compound proposition can also be determined. A conjunction is true when both conjuncts are true. Otherwise, its value is false. In other words, if at least one of the conjuncts is false, the conjunction is false. Now, one way to represent the possible truth values of a compound proposition is to use a truth table. A truth table shows the truth value of a compound proposition for all possible values of its components. Thus, for conjunction, we have the following truth table. As you can see there, you have P and Q and P and Q, the conjunct of the proposition P and Q. As it is said, the conjunction of P and Q will only be true if and only if the two propositions are true. If both propositions are true, then the conjunct is also true. Otherwise, its value is false. The following words can also be used to form a conjunction aside from the word "and". We have but, whereas, nevertheless, still, despite, moreover, yet, although, furthermore, while, and however. Let's proceed to the second type of a compound proposition. It is called disjunction. A disjunction is formed when two simple propositions are joined using the connective "or". The disjunction of two simple propositions, P and Q, has the form P or Q. In symbols, we write it as P and like a letter V and Q. The propositions P and Q are called disjuncts. A disjunction is false when both disjuncts are false. In short, a disjunction is true when at least one of the disjuncts is true. So the truth table below shows the truth value for disjunction. Here, as you can see, a disjunction of a compound proposition will only be false if the two simple propositions are false. Otherwise, it is true. The following can also be used to form a disjunction. You can use else, either or, unless. The third type of a compound proposition is called conditional. A conditional proposition takes the form if P then Q. In symbols, we write it as P with an arrow going to the right, Q. The proposition P is called the antecedent, while the proposition Q is called the consequent. Conditional is false when the antecedent is true and the consequent is false. Otherwise, it is true. In truth table, form the truth value of a conditional proposition can be described as follows. As you can see, a conditional is only false if, only if, the antecedent is true and the consequent is false. Otherwise, it is true. Another term for a conditional proposition is implication. The following has the same meaning as the proposition if P then Q. We have Q if P, Q granted P, P only when Q provided P, Q is necessary for P entails Q given P only if P is sufficient for Q, and Q in case P. The fourth type of a compound proposition is called biconditional. A biconditional proposition has the form P if and only if Q. In symbols, we write it as P with an arrow going to the right and left, Q. A biconditional is true when both components have the same truth values. The following truth table describes the truth value of a biconditional proposition. As you can see, if the components, the P and Q, have the same truth values, that is the only case that a biconditional will be true. So we have here both true, so therefore the biconditional proposition is true. Both are false, therefore the biconditional proposition is also true. Otherwise, it is false. The following can be used to replace P if and only if Q. We have P when and only when Q. In order for P, it is necessary and sufficient that Q. P just in case Q. A necessary and sufficient condition for P is Q. Or P granted that and only granted that Q. Let's have some examples. Consider the following propositions. Proposition R, it is a sunny day. Proposition T, we will go to the park. Now, we are asked to form a conjugation, a disjunction, a conditional, and a biconditional out of the given simple propositions. So how are we going to form a conjunction? For the conjunction, we have it is a sunny day and we will go to the park. See, we are using the connective and for the conjunction. How about for the disjunction? Either it is a sunny day or we will go to the park. So we are using the connective either or for the disjunction. For a conditional, if it is a sunny day, then we will go to the park. So we are using the connective if then. For a biconditional, it is a sunny day if and only if we will go to the park. So we are using the connective if and only if. Note that the other words that have the same meaning as the connectives used may also be utilized to form the compound propositions. Another example. Okay, let J and Y represent the following propositions. J, we have June has 31 days. Y, there are 12 months in a year. So we are asked to determine the truth value of the following compound propositions. J and Y, J or Y, J conditional Y, Y conditional J. So in number 3, the antecedent is J, the consequent is Y, Number 4, it will be y that becomes the antecedent and the j will be the consequent. Number 5, j by conditional y. So first thing that we need to determine is the truth value of its proposition. So let's check. June has 31 days. Is it true or false? Very good. It is false because June has only 30 days. How about the proposition y? There are 12 months in a year. Is it true or false? Very good. It is true. We can determine the truth table of the following compound propositions. So let's start with number 1, a conjunction. J conjunct with Y. So our J is false and our Y is true. Therefore, the conjunction of J and Y prepositions is false. Why? It is because from the definition of a conjunction, it will only be true if both components are true. Otherwise, it will be false. Since our proposition J is false, therefore the conjunction is false. Number 2, J disjunction Y or J or Y. So let's formulate the truth table. Our J is false, our Y is true. So what is now the disjunction? The disjunction is true. Why? Because from the definition, it says that a disjunction will only be false if both components are false. Now, since our component y is true, therefore the disjunction is true. Number 3, we have j conditional y. So our antecedent is the j and our consequent is y. Okay, so when we make the truth table, our j is false, our y is true. To conclude, this conditional proposition is true. Why? It is because from the definition it says that if the antecedent is true and the consequent is false, then the conditional is false. Otherwise, it is true. Now, in this case, our antecedent is false and our consequent is true. Therefore, our conclusion is true. How about in number 4? In number 4, our y now is the antecedent and our j is the consequent. Now, from the definition, it says that if the antecedent is true and the consequent is false, then therefore it is false. So what is our antecedent here? Our antecedent is y, and y is true. And the consequent is false, our j. So therefore, we can conclude that this proposition is false. Number 5, we have j biconditional y. So if you're going to create a truth table, we have j false for the y is true. So the biconditional is false. Why? Because from the definition, it says, for a biconditional proposition, it will only be true if both components have the same truth values. And in here, as we can see, that these components, the j and the y prepositions, they do not have the same component. Therefore, our conclusion is false. Let's proceed to example number 3. So we are asked to symbolize the following combined propositions and determine their truth values. So number 1, 3 is a prime number, but square root of 5 is irrational. So let's symbolize the first proposition, which is 3 is a prime number. let's symbolize it with P. And square root of 5 is irrational. Let's symbolize it with Q. So as you can see, this is a conjunction. Why? Because of the connective but. Let us now determine the truth value of its proposition. So for the proposition P, 3 is a prime number. Of course, it is true. And Q, which is the square root of 5, is irrational. Of course, it is also true. So, using the definition of a conjunction, it's P and Q, we can formulate now the truth value, the truth table. If P is true and Q is true, we can conclude that the conjunction of P and Q is also true. Number 2, either the province of Laguna is in Region 5 or Metro Manila is in NCR. So let's represent the first proposition, which is the province of Laguna is in Region 5 with the letter P. Metro Manila is in NCR with the letter Q. First, let us take a look at the compound proposition. We are using either or. So therefore, it is a disjunction. Now, let's take a look. Let's examine the truth value of its propositions. First, the province of Laguna is in Region 5. True or false? It is false. Metro Manila is in NCR. Is it true or false? It is true. Now, let's create the truth table. So we have P or Q. Now, from the definition of a disjunction, it says that it will only be false if both components are false. But here, as you can see, our first component is false. The second component, Q, is true. Therefore, we can conclude that this compound proposition is true. Number 3. A car has 4 wheels, provided that a chicken has 2 legs. Okay, so let's symbolize now the propositions. Let P be a car has 4 wheels, and Q be a chicken has 2 legs. Now again, let's read. A car has 4 wheels, provided that a chicken has 2 legs. So in here, we are using the connective provided that. So provided that is a conditional connective. Okay, so now let's examine its truthness or falseness of the proposition. So a car has 4 wheels. Yes, it is true. A chicken has 2 legs. Yes, it is true. As we have said, it is a conditional. It is a conditional proposition. So we have P with an arrow going to the right, Q. So P is our antecedent and Q is our consequent. So forming now the truth table, we have true for the P, true for the Q. Therefore, we can conclude that P conditional Q is true. Why? Because from the definition of a conditional will only be false if and only if the antecedent is true and the consequent is false. Now, but in this case, since both components are true, therefore it is true. Example number 4. A triangle has 3 sides if and only if a rhombus has 5 sides. So again, we are using the connective here, if and only if. Therefore, it is a biconditional. So let's now symbolize the propositions. Let P be a triangle has 3 sides. Q, a rhombus, has 5 sides. Let's examine if it's true or false. A triangle has 3 sides. Yes, it is true. A rhombus has 5 sides. Of course, It is false. Okay, so forming now a biconditional table. Okay, so we have this. Our P is true, our Q is false. Therefore, we can conclude that this biconditional compound proposition is false. Why? Because from the definition, it says that if both components have the same truth values, then the biconditional is true. Otherwise, it is false. And in this case, they are not the same, therefore, it is false.